Hello everyone, you're welcome to this tutorial. In this tutorial, we are going to be discussing the limiting value of a function, which is a continuation of the calculus series that we have currently. So basically, when we're talking about the limiting value of a function, in layman terms, I do categorize it using this 1, 2, 3, 4 procedure that I've listed below, which is direct substitution, factorization, L'Hospital's rule, then infinity rule. Now, one thing I need you to know is that because as you are progressing in calculus, uh, this is going to be subject to a little change, especially when you start discussing limit of a function, the Cauchy's definition of limit of a function, and the rest. So, but this is just to summarize it as a kind of introduction if you are just starting calculus. Now, basically, we're going to start with the first one, which is direct substitution. Now, let's consider a limiting value of a function question, which let's say that we have that we are to evaluate, let me put this as a, we are to evaluate the limit as x tends to 3 of x plus 3. Now, if we are to evaluate the limit as x tends to 3 of x plus 3, direct substitution, it means that what you have here, it is tending to a number here, or it can even tend to a letter. It's not always the time that it can tend to a number. So direct substitution simply means that the value that you have here, you directly substitute it into your equation if it works. Now you discover this, if we substitute x to be 3 into this expression that we have here, that expression becomes, instead of writing x, that will be 3 plus 3. And 3 plus 3 is going to give us 6. So therefore, it means that the limit as x tends to 3 of x plus 3 is equivalent to 6. So for this question, direct substitution worked. So it means that for every question, when you're finding the limiting value of a function, you first start with direct substitution. If direct substitution fails, you go to factorization. If factorization fails, that is when you go to L'Hospital's rule. Then for the infinity rule is when your x is tending to infinity, in which we are still going to get it. So let's take another example. Let's say we have example 2. We are to evaluate the limit as x tends to 2. Let's say x squared minus 4 divided by x minus 2. Now in this question, if we use direct substitution, if x is equal to 2, substituting it, let me do it up here, that'll give us 2 raised to power 2 minus 4 divided by 2 minus 2. Now the denominator here is going to give us 0. And you discover that once you have 0 as your denominator, your solution automatically becomes undefined. So in this case, we don't just have 0 at the denominator. The numerator also gives us 0, which makes the solution indeterminate, not just undefined. So from here, what it means is that direct substitution has failed in this question. So if I put an x there, direct substitution has failed. Now we check factorization. Since this is a fraction and we have a numerator and we have a denominator, we take this denominator as the divisor. Now you check the denominator, is it a factor of the numerator? Now you discover that the numerator, which is x squared minus 4, can be left as limit as x tends to 2 of x squared minus 2 raised to power 2, because 2 raised to power 2 is the same thing as 4, divided by x minus 2. So this is the same thing as limit as x tends to 2 of x squared minus 2 squared in mathematics signalizes with difference of 2 square. So it means that from difference of 2 square in maths, you know that a square minus b square is the same thing as a minus b multiplied by a plus b. So what it means is that x square minus 2 square would be the same thing as x minus 2 times x plus 2. So here, this will give us x minus 2 multiplied by x plus 2 divided by x minus 2. Now, x minus 2 will cancel x minus 2. This will be left with limit as x tends to 2 of x plus 2, because this has cancelled this. So it means that if if direct substitution fails, and use factorization to reduce the fractional form, eliminating the divisor, you would get back a limiting value of a function question that you'll be able to use direct substitution to solve. So from here, limit of x tends to 2 of x plus 2 will simply give us 2 plus 2, and that'll give us 4. So it means the final answer to this question is going to be 4. Now, for L'Hospital's rule, L'Hospital was a French mathematician who postulated a rule after his name, which is L'Hospital. And the rule actually determines the limit of function whose existence does not occur. So, for example, let's consider, let me say, example 3. Let's say we have limits as x tends to 2 of x square plus 4 divided by x minus 2. Now, in this case, you discover that x squared plus 4 can't be easily factorizable to give you x minus 2 as a factor, because we know that from algebraic equations, or let's say quadratic symmetric properties of roots, alpha square plus beta square is going to give us alpha plus beta or square minus 2 alpha beta. So if we are to try and factorize this, x squared plus 4 will give us x plus 2 raised to the power of 2 minus, that will be minus 2 times x times, that will be minus 4x. So basically you can factorize x minus 2 out of this. So it means that this is not factorizable. So that is where all of L'Hospital's rule comes into play, because you'll be able to determine the limit of a function because the existence of this particular equation does not occur. So we are now going to find the limit of the function by direct substitution of the given neighborhood. Now, what do we mean by the given neighborhood? The definition for L'Hospital's rule simply states that when you're given your h of x, let's say h of x is equal to f of x over g of x, and you are looking for limit of h of x as x tends to x naught, it will be equivalent to limit of f prime of x naught. Okay, since we have taken x, or let's just leave it as f prime of x over g prime of x as x tends to x naught. So what it means is that L'Hospital's rule simply means that you differentiate the numerator. The numerator here is f of x. When you differentiate of f of x, you get f prime of x. So you should be careful, because f prime of x is not the same thing as f inverse of x. This is basically used in mapping and function, but in differential calculus, f prime of x is the same thing as dy dx. So what it means here is that if your numerator here is f of x, if you differentiate it, you get f prime of x. Your denominator here is g of x. If you differentiate it, you get g prime of x. So if we use the same concept here, your h of x is the whole of this, which is x squared plus 4 divided by x minus 2. Then your x tending to x naught, your x naught here is 2. So if I say that limit as x tends to 2, applying L'Hospital's rule, I'll differentiate x squared plus 4. If we differentiate x squared, we are going to get 2x. If we differentiate 4, we'll get 0. Divided by, if we differentiate x, we get 1. If we differentiate minus 2, we get 0. So this will reduce to limit as x tends to 2 of 2x, because 2x over 1 will give us 2x. And what this means is substituting x as 2, that will give us 2 times 2, which will eventually give us 4. So that's the basic application of L'Hospital's rule. So one thing you need to know is that you don't use L'Hospital's rule directly. You only use L'Hospital's rule if direct substitution failed, if factorization also failed. That is when you use L'Hospital's rule. So, but if direct substitution works, your correct answer is going to be subject to direct substitution. If it is factorizable, your correct answer is going to be subject to factorization. But only when these two fails, that's when you use the L'Hospital's rule. Now, the last rule that we have there is the infinity rule, which I've told you is only applicable when your x is tending to an infinite number, which is always represented as infinity. So now let's take a look at an example. Let's say we are to find the limit as a tends to infinity of 3 plus 5a squared divided by a plus a squared. Now I want to find the limit as a tends to infinity of 3 plus 5a squared divided by a plus a squared. Now the first step in the infinity rule is that when your value is tending to infinity, the first step you need to do is that you need to identify the term that has the highest order. What did I just say? Order. Order is a synonym of power. So looking at this example, you discover that the highest power that you have here is 2. After 2, we have 1 here, which is a raised power 1. After 1 here is the constant that we have here, which is a raised to power 0. So 3 is the same thing as 3a raised to power 0. What I mean, let me write this out here in terms of their power. So we have 3a raised to power 0 plus 5a raised to power 2 divided by a raised to power 1 plus a raised to power 2. So this is in representation of all the powers. Now the first step is that you need to divide through by that term that has the highest power. The term that has the highest power here is a raised to power 2. Also here we also have that same a raised to power 2. So every element that we have in that fraction is going to be divided by a raised to power 2. So this question will then give us limit as a tends to infinity of 3 over e squared plus 5e squared divided by e squared divided by e over e squared plus e squared divided by e squared. So this gives us limit as a tends to infinity of 3 over e squared plus e squared in 5a squared, that will remain 5, plus a divided by a squared, that will give us 1 over a squared divided by a squared, that will give us 1, So limit as a tends to infinity will then give us, okay, so let me circle this back. Now we have gotten 3 over a squared plus 5 divided by 1 over a plus 1. Now after you divide through by a squared and you have simplified it to the lowest term, you substitute infinity now as a direct substitution. So this will give us 3 divided by infinity square plus 5 divided by 1 over infinity plus 1. Now mathematically we can assume when we are dividing by infinity, take a look at this. If we say 1 divided by 1, we get 1. If we say 1 divided by 2, we get 0.5. If we say 1 divided by 3, we get 0.333. If we say 1 divided by 4, we get 0.25. If you say 1 divided by 5, we get 0.2. Now, one thing that you discover is that the number, as the denominator is increasing, what you are getting will keep on decreasing. So you get to a point when you say 1 divided by 100, that will give you 0.01. You get to some bigger numbers, 1 divided by 1 million, you get 0.000001, and so on. So now, imagine that you are dividing just a single number by the biggest number, which is infinity, the biggest number that you have in this world. So it means that the answer will be 0.000000. The answer is not actually 0, but it approximately tends to 0. So it means that if you divide 3 divided by infinity, it will approximately equal to 0. Now imagine infinity. You square the biggest number that we have in this world, then you say 3 divided by that number, it will automatically still give you 0. So this will give us 0 plus 5. 0 plus 5. Let me write it here. So this will give us 0 plus 5 divided by 0 plus 1. So this is 5 over 1, and the final answer will give us 5. So we have gotten the final answer to be 5. Let's consider another question. Let's say we're given as limit as x tends to infinity of, let's say, 2 plus 3x plus 4x squared plus 7x raised to the power 3 divided by 1 plus 9x minus 3x squared plus 5x raised to the power 3. So the first step, you divide by the highest power. You identify the highest power here, which is x raised to the power 3. So this gives us limits as x tends to infinity of 2 over x raised to the power 3 plus 3 over x squared plus 4 over, that's 4 over x plus 7 divided by 1 plus 9 over x squared minus 3 over x plus 5. So substituting infinity, this gives us 2 over infinity raised to the power 3 plus 3 over infinity raised to the power 2 plus 4 over infinity plus 7 divided by 1 plus 9 over infinity square minus 3 over infinity plus 5. So this will automatically give us 0 plus 0 plus 0 plus 7 divided by 1 plus 0 minus 0 plus 5. So in this 1 over, we didn't divide this, so this is 1 over x raised to the power 3. So this is 1 over infinity raised to the power 3. So this is not 1, this will be 0. So this will automatically give us 7 over 5. So it means that the limiting value of this function as it takes to infinity is equivalent to 7 over 5. So basically this is the prerequisite or the beginning for limiting value of a function, catching the next tutorial.